Calculating electrical box fill is a crucial step in any electrical job. It is not just a suggestion, it is a requirement outlined in the National Electrical Code, specifically in Section 314.16a. Neglecting this calculation can lead to several problems, ranging from difficulty in closing the box cover to serious fire hazards. The primary reason for calculating box fill is to ensure there is adequate space within the electrical box for all the conductors, devices, and any necessary fittings. Overcrowding can cause conductors to become pinched or damaged, leading to short circuits, insulation breakdown, and ultimately, the risk of electrical fires. The NEC specifies the maximum number of conductors allowed in a box based on its size, conductor size, and the presence of devices or fittings. The calculation itself is straightforward, but it requires a systematic approach to account for all elements within the box. Here's a breakdown of how to calculate box fill using NEC Table 314.16a. Firstly, you need to determine the volume of the electrical box. This information is usually stamped on the box itself, indicating its cubic inch capacity. If it's not stamped, you'll need to measure the internal dimensions of the box and calculate the volume. Secondly, identify all the conductors entering the box. This includes all hot wires, neutral wires, and ground wires. Each conductor entering the box counts towards the total fill capacity. Thirdly, account for conductor equivalents. The NEC doesn't count each conductor equally. Instead, it assigns an equivalent volume based on the wire gauge. For example, a number 14 American wire gauge conductor has a smaller equivalent volume than a number 12 American wire gauge conductor. The equivalent volume for each wire gauge is listed in NEC Table 314.16b. Fourthly, factor in device fill. Devices such as switches, receptacles, and equipment grounding conductors also contribute to the box fill. For each device, you must add two conductor equivalents based on the largest conductor entering the box. This means that if you have a box with number 12 and number 14 American wire gauge conductors, you use the equivalent volume for number 12 American wire gauge conductors when calculating the device fill. Fifthly, include conductor fill for any grounding conductors. Grounding conductors also take up space within the box. The NEC allows you to count all grounding conductors as a single conductor equivalent based on the largest grounding conductor entering the box. Sixthly, consider any cable clamps or fittings. If the box has internal cable clamps, you must add one conductor equivalent to the box fill calculation based on the largest conductor entering the box. Now, let's illustrate with an example. Suppose you have a 4-inch square metal box with a volume of 30.3 cubic inches. Inside the box, you have the following conductors: 5 number 12 American wire gauge conductors, 3 number 14 American wire gauge conductors, 1 receptacle, and 2 equipment grounding conductors, with the largest being number 12 American wire gauge. The box also has internal cable clamps. Firstly, we need to find the conductor fill for the number 12 American wire gauge conductors. According to NEC Table 314.16b, each number 12 American wire gauge conductor has an equivalent volume of 2.25 cubic inches. Since we have 5 of them, their total fill is 5 multiplied by 2.25, which equals 11.25 cubic inches. Secondly, we calculate the conductor fill for the number 14 American wire gauge conductors. According to NEC Table 314.16b, each number 14 American wire gauge conductor has an equivalent volume of 2 cubic inches. Since we have 3 of them, their total fill is 3 multiplied by 2, which equals 6 cubic inches. Thirdly, we account for the device fill. The receptacle counts as 2 conductor equivalents based on the largest conductor, which is number 12 American wire gauge. Therefore, the device fill is 2 multiplied by 2.25, which equals 4.5 cubic inches. Fourthly, we include the fill for the grounding conductors. All the grounding conductors can be counted as 1 conductor equivalent based on the largest grounding conductor, which is number 12 American wire gauge. So the grounding conductor fill is 2.25 cubic inches. Fifthly, we account for the cable clamps. Since the box has internal cable clamps, we add one conductor equivalent based on the largest conductor, which is number 12 American wire gauge. Therefore, the cable clamp fill is 2.25 cubic inches. Sixthly, we sum up all the individual fills. The total box fill is 11.25 plus 6 plus 4.5 plus 2.25 plus 2.25, which equals 26.25 cubic inches. Finally, we compare the total box fill to the box volume. The box volume is 30.3 cubic inches, and the total box fill is 26.25 cubic inches. Since the box fill is less than the box volume, the box is compliant with NEC requirements. If the total box fill exceeded the box volume, you would need to either use a larger box or reduce the number of conductors, devices, or fittings in the box. It's important to note that this is a simplified example. In real-world scenarios, you might encounter more complex situations with different wire gauges, multiple devices, and various types of fittings. However, the basic principles remain the same. Always refer to the latest edition of the NEC and consult with a qualified electrician if you have any questions or doubts. In addition to ensuring code compliance and preventing fire hazards, calculating box fill also promotes good workmanship and professional conduct. It demonstrates that you are taking the time and effort to do the job correctly, which can enhance your reputation and build trust with your client. Furthermore, proper box fill can also improve the longevity and reliability of the electrical system. When conductors are not overcrowded, they are less likely to overheat or become damaged, which can extend the lifespan of the wiring and reduce the need for costly repairs. Therefore, calculating electrical box fill is not just a technical requirement, it is an essential aspect of safe, reliable, and professional electrical work. It is a practice that should be embraced by all electricians, regardless of their experience level. By taking the time to perform this calculation, you can protect yourself, your clients, and the public from the potential hazards of overcrowded electrical boxes. Remember, safety is always the top priority in electrical work. Do not cut corners or take shortcuts that could compromise the integrity of the electrical system. Always adhere to the NEC and follow best practices to ensure that the job is done right. Also, consider the type of conductors being used. The NEC differentiates between different insulation types such as THHN, THWN, and XHHW. Each type has different temperature ratings and suitability for different environments. Make sure to select the appropriate conductor type for the specific application and environment. Furthermore, be aware of any local amendments or variations to the NEC. Some jurisdictions may have additional requirements or modifications to the code. It's important to stay informed of these local regulations to ensure compliance. In addition to calculating box fill, it's also important to consider conduit fill. Conduit fill refers to the percentage of the conduit's cross-sectional area that is occupied by conductors. The NEC limits the maximum conduit fill to prevent overheating and damage to the conductors. The conduit fill calculation is similar to the box fill calculation, but it involves different tables and formulas. Always refer to the NEC for the specific requirements for conduit fill. Another important consideration is the proper grounding and bonding of electrical equipment. Grounding and bonding are essential for protecting people from electrical shock and preventing electrical fires. The NEC provides detailed requirements for grounding and bonding, including the size and type of grounding conductors, the methods of connecting to ground, and the bonding of metal enclosures. Always follow these requirements carefully to ensure a safe and effective grounding system. When working with electrical systems, always use appropriate personal protective equipment, or PPE. This includes safety glasses, gloves, and insulated tools. Also, be sure to energize the circuit before working on it. Use a voltage tester to verify that the circuit is dead. Never assume that a circuit is de-energized. Always test it to be sure. If you are not comfortable working on electrical systems, it's best to hire a qualified electrician. Electrical work can be dangerous, and it's important to have the knowledge and skills to do the job safely. By following these guidelines and adhering to the NEC, you can ensure that your electrical work is safe, reliable, and compliant with all applicable regulations. Calculating box fill is a fundamental aspect of electrical work that should not be overlooked. It's a simple and quick process that can have a significant impact on the safety and reliability of the electrical system. So take the time to do it right.